Okay, this video is example 1 for one sample t-test, also known as the hypothesis testing for the t-distribution. So we have a random sample of 10 weeks, so that's going to be our sample size, 10. Then we have, that sample has a sample mean, that's x bar. We have a sample standard deviation, so that's our S. And the only thing we're missing is going to be our mu. So the keywords for this are going to be all, historically, previous research. So here we know that they claim. Claim is also kind of a good keyword to look for the whatever the parameter is going to be, which in this case is the population mean, 16.3. My alpha is going to be 0.05. The next thing I have to do is find my pair of hypotheses. I'm going to start with my null. Remember, it's always going to be a parameter, so a Greek letter, mu. The null hypothesis is always going to be equal, and we know what it's equal to. It's right here, so 16.3. The alternative also needs to have mu, and it needs to have whatever mu equals to, which is 16.3. But we need to fish for the symbol that we are interested in the problem. So in this problem, they actually do not give us a direction like greater than, less than, so whenever we don't have that aid for the keyword, what we're going to test for is difference. And actually, the different or two-tailed tests are very popular. Most of the time, this is what software will do by default. So now we're going to find our critical value, which I label T crit. Why do I like putting the crit in there? To remind you, is the critical value and not to confuse it with what we're going to calculate, which I label as T obtained. So the critical value comes from the table. So it's actually a theoretical value. So we're going to need the T table. We need the alpha. And in this case, we're going to need the degrees of freedom, n minus 1. So that's going to be 10 minus 1 equals 9. From here, we go to the table. So I'm in the T table. I'm going to do a two-tailed because it had the symbol different in the alternative. My alpha is 0.05, so it's right there. My degrees of freedom was 9. So I just find, there it is, the value there, so it's 2.262. So don't forget it was a two-tailed test. That's why I look for two-tail in the table. And my T crit would be 2.262. Because it's two-tail, we need to put the plus minus in there. So now we're going to find the test statistic. Another name for this would be test value. And kind of like the label that I use for it is T obtained, just to differentiate it from the one you get from the table. This is going to be an empirical value. So if we actually were collecting data, it would be the one that we get from our data set. Here we're kind of pretending we already have the data. That's why we don't make that. The difference isn't very subtle for us. So T obtained, this is going to be my formula. X bar minus mu S divided by the square root of n. So my X bar was 17.7 minus mu, 16.3, divided by the sample standard deviation, square root of 10, I believe. There you go. So when I do the top part, here, I got 1.40. When I do the denominator here, I got 0.57. And then finally, I do this division. And that's going to be 2.46. That is my T obtained. We're going to make a decision based on the critical value, T crit, and T obtained. So let me draw the curve. This is a t distribution curve. Remember, the mean is going to be here, 0. Everything to this side is going to be positive t-scores. Everything to the left side is going to be negative t-scores. So t cred was positive 2.262. And let me shade the area. This is what we call the rejection region. T cred is negative 2.262. We have 2 because it's two-tailed. Now we need to place our test value or test statistic here. That was 2.46, so it would actually be over here. T obtain 2.46. So because it's in the rejection region, or we can say because it's bigger than t critical, we reject the null hypothesis. So the next method that we're going to use to determine whether we reject or not the null hypothesis is the p-value method. So usually we're going to get the p-value from technology. Here I already have the table, what it would look like in Jamovi. My p-value is here, degrees of freedom are here. This is going to, statistics is basically the test statistic, what we calculated. This is our alternative hypothesis. I have this little diagram in our notes, so make sure you look at it when you need to make this decision. Basically what we have to do is compare the p-value to our alpha, which is 0.05, and in this case we know that our p-value is less, oh, that was not a good color, less than our alpha. When the p-value is less than alpha, we have statistical significance and we reject the null hypothesis. Reject the null hypothesis. So it gave us the same conclusion as when we were looking at the critical value and we drew the little curve. Those two methods should align. If they don't align, I probably made a mistake. I try not to, but it could happen. The two methods are doing the same thing. That's why they should get the same results. From here, we have all the information that we need to write our conclusion. So now all we have to do is write our conclusion. First, we need the name of the test. I call it one sample t-test. That's what Jamovi calls it. But you could also say, I did a hypothesis test using the t-distribution. That's also appropriate because that's exactly what we're doing. The next thing you have to do is tell me the significance level. So that's what I did, using a significance level. So if people want to check whether what you're saying is true, whether you do reject the null hypothesis, whether you do have statistical significance, they need to look at both the p-value and the alpha to make that comparison. That's why we're putting it here. Next, you need to tell me what was your decision, whether you reject it or not. So here I have a sentence, we reject the null hypothesis. And we did this based both on the critical value and on the p-value. That's why those two methods need to align. There was overwhelmingly statistically significant evidence. So there's two parts to this. Where did I get the overwhelmingly? I got it from this table. It's from Ward and Nolte, 2023. I have it in my notes and you can just cite that. Just recall, so we're here. If the p-value is greater than alpha, then it's not in the table because it's not statistically significant. So my p-value is here, 0.036. So it's between these two values, so I called it overwhelmingly. The next thing is, how did I know that it was statistically significant? Well, the p-value was less than the alpha, so it's here, statistical significance. And then I have a little sentence about, the problem, whatever we were claiming. So there was evidence that it was different than the mu. So this piece is essentially our alternative hypothesis, mu different than 16.3. You just say it in words rather than putting the null hypothesis in there. Finally, we have the APA notation. So that's going to give us the t, that's the distribution we're using. Here we have the degrees of freedom, that's 9. This is what we calculated, the test statistic or test value, and we also get it from Jamovi. It's labeled just statistic. And then we have our p-value. This one we always have to get from technology.